Okay. The last time I saw you last week, we had your Unit 2 test, and then we had the pre-test for Unit 3. The Unit 2 test had a section where you were finding either an input or an output, and then where I asked you for domain and range. That's the part that sort of across the board we all kind of struggled with. So this week, we are going to have a warm-up problem every day about input and output and about domain and range. And then on Friday, we are going to have basically page 2 of the test again. Okay, so I'm going to put it in as a quiz. It'll be just input, output, domain, and range. It's not going to be everything that we saw in the Unit 2 test, but it's going to be the material that we struggled with. Nobody got all of the domain and range questions correct. So we need some work on this stuff. And most of us struggled with the input, output questions. So I want everybody to start on the front side of this paper, the part that has a spot for you to write your name. And we're gonna take a look at the setup here and go through those day 1 questions. So we've got 3 different functions here. This is really similar to what you saw in your test. We have f of x, where I'm given an equation. We have g of x, where we've got a table. And then we have h of x, which is a graph. So what we're going to look at here is just a little refresher of how we find input and output on these things. Because this, again, is where most of us struggled on the test that we had last week. So for the day 1 problems, the first question I asked you is, what is f of 2? I'm used to seeing an x in this spot, right? So when I see a number there instead, that means I'm plugging into for x in that function. So I'm going to take my function and I'm going to plug into for x. And then I'm going to simplify. That's what I'm asking you to do here. So as I simplify, remember to follow order of operations. 2 times 2 would be 4. So we've got 4 plus 4, which is 8. So that tells me that f of 2 equals 8. The other option is that you've still got x in that spot, but I've told you what it's equal to. So this we thought of as basically our y value. I told you what this simplifies to. You're trying to figure out the x that made it simplify to that number. Now we're using g of x for the second problem. That means we don't have any solving to do like we would if we were looking at, say, our day 2 problem with f of x. So we'll get there. So what we're going to do here is just look at our table, because that's g of x, and we're going to look at where that y value is 4 and give the x value. That's what we're missing here. What x value gave me this? So that would be 2. So if my function value, my y value is 4, that means my x value had to be 2. And then for our last problem here, h of x equals 3. Again, I've got the y value this time. I want to figure out what x is equal to. So on my graph, I'm going to go to where y is 3. That's right here. Follow that to the point on my graph that has a y value of 3. That'd be this guy. This would be -1, 3. So the x value would be -1. The x value that's going to have a y value of 3 would be -1. That's what I'm looking for there. What was that missing x? So we're going to do some input-output practice every day this week as a little warm-up, okay? Questions on input-output. The other thing that we're going to look at this week, if you flip to the other side of your paper, the other thing that we're going to look at is domain and range. Again, nobody got a perfect on the domain and range problems, okay? So that tells me that we need some more work here. So we've got a couple different functions that we're going to look at. We've got f of x, h of x, and g of x. We've got some different graphs here. And we're going to talk about domain and range, again, as part of our warm-up every day this week. So for our first problem, I want to give the domain of f of x. So I'm looking at this graph here, f of x. And remember, domain refers to our x values. When we're giving the domain, we're going to start by stating the lowest x value we can have, and then the highest x value we can have. Tomorrow, we're going to look at the range of f of x, and so then we'll look at the y values. But for today, we're looking at x. So our lowest x value we can possibly have would be the point that is farthest to the left. So that'd be this guy right here. Notice it's a filled in point, and it is a point on the graph. So that x value is 1, 2, 3, -3. So my smallest x value is -3. My largest x value would be the point that is farthest to the right. So that would be this guy, and its x value is 4. There's two parts I need to worry about for domain and range. The first part is the values, which we've got now. The second part I need to worry about are parentheses versus brackets. Okay, parentheses versus brackets. So because we've got filled in points here, and my graph doesn't continue on forever, we don't have any open circles like h of x has, that means that -3 is an x value that I can have, and +4 is an x value that I can have. So we want to use brackets here. I can have each of those values as x, so I want to use brackets. Okay. We'll see as we continue through these problems this week, cases where we want to use parentheses instead, but for this guy, we're going to use brackets. Questions for me on our warm-up problems for today? Okay, so hang on to this paper. We're going to come back to it every day this week. And then on Friday, we're going to do what I'm going to call a quiz over input, output, and domain and range. We're gonna try that section of that Unit 2 quiz again. The next thing we're going to take a look at is the start of Unit 3. So Unit 3 is all about linear functions. We are vaguely familiar with linear functions, as I saw from our pretest last week. So what we're going to look at in this unit are graphs of linear functions, writing linear functions, tables that represent linear functions, different equations I could use to represent linear functions. There's the different format options I have, and then key features of these linear functions. So we'll talk about x and y intercepts again. We'll talk about slope. We'll talk about everything that is an important feature or property of linear functions. So when we talk about linear functions, we're going to look at something that has a line or something that has to do with a line, okay? And the word line is in linear functions. So we're looking at lines. Let's take a look at our first scenario here. It says a cab charges a $3 boarding fee and then $2 per mile. We've actually seen examples similar to this back in Unit 1. One of the points I had to clarify when we looked at a similar problem in Unit 1 was this $2 per mile. Does that mean we can only travel whole miles in the cab? No. So if my destination is 7.8 miles away, they're not going to stop at 7 miles and say, you either have to get out here and walk the rest of the way, or I drive you 8 miles and then you backtrack a little bit, right? I don't have to just travel in whole miles, but that's how they're stating that fee. That's the easiest way for them to state that charge. So a cab charges a $3 boarding fee and then $2 per mile. Let C of X calculate the cost of a trip based on the number of miles of the trip. And so they've given me that function here, okay? What does the 2 represent? Where did they get that 2 from? It's the cost per mile, right? And we're going to see stuff like this a lot in our linear functions unit. There's some sort of recurring change, in this case, a recurring charge. The 2 is our cost per mile. And then how about the 3? Mm-hmm. That's that boarding fee. So we have our cost per mile and our boarding fee. And then we've got a graph representing our function here. The next thing we're going to talk about are domain and range. So some more good practice for us. So domain, remember that's going to be our X value. Range is our Y. And our X in this case represents the number of miles that we've traveled. Our Y represents the cost of our trip. So I want a reasonable domain here. I'm talking about a reasonable number of miles I may travel in a cab. What's the low end that I would be looking at here? Mm-hmm. Yeah, does negative numbers make sense? No, I can't travel negative amount of miles because no matter what direction I'm going in, I'm still traveling some number of miles. So I can't have anything negative. And we kind of got that hint from our graph here. And then let's talk about 0 per second. Would it actually make sense to hail a cab and say, actually, I'm not going to drive anywhere in your vehicle. Have a great day. So 0 as a value for this function doesn't make a ton of sense, but anything bigger than 0, would that be reasonable? So for our domain, we do want to start it at 0, but because 0 itself doesn't make sense, we're going to use a parenthesis here. Okay. Now, maybe you personally wouldn't call a cab if it's going to be less than a mile because you'd prefer to just walk, but maybe that's circumstance depending. If you're carrying a lot of heavy stuff, you might not want to walk. If it's pouring down rain or really cold outside. So we'll go anything bigger than 0 is fair game. And then, is a cab going to take me as far as I may possibly want to go? Depends, but a lot of them are probably going to have an upper range. Okay, at some point they'll say, because remember, wherever that cab drives you to, they have to drive back to wherever they started. Okay, so if you're in Metamora, is a cab going to want to take you to Indianapolis? Probably not. Maybe for an extra fee, they might, but likely they're going to say, I have a radius of this much. I'll only travel this far. So maybe they'll take you to Bloomington, but not Indianapolis. Now, whatever that top range is going to depend on the individual driver. So for our domain, I'm just going to put a question here for right now. And we'll talk about that more in just a minute. And then let's talk about our range. So we said we start our domain at 0. So if I were to drive 0 miles, and technically, because we have that parenthesis, we said anything bigger than 0 miles. So if I were to start at 0 miles, that means that my cost is going to have to start at $3. Does that make sense? Now, since we're not actually going to travel 0 miles, we said anything bigger than 0, our range then would be anything bigger than 3. Does that make sense? So if our domain is anything bigger than 0, and we plug in 0 for x, our range has got to be anything bigger than 3. And then our range will go to whatever this question mark ends up being. So I'm going to sort of leave it in general terms to start. So the top of our range would be 2 times whatever this number of miles is, plus 3. Let's say that our top number of miles our driver's willing to go is 20. So just under here, I'm going to do an example. Let's say they're willing to go 20 miles, no farther. That means that our range would be 2 times 20 plus 3. So that would be 40 plus 3. So our range would end at 43. If my driver's only willing to go a maximum of 20 miles, then the biggest fare they can collect is going to be $43. Does that make sense? Okay. Questions for me on scenario A? Okay, let's take a look at B. Got another linear situation here. It says Sarah was given a $100 Starbucks gift card and uses it to buy $5 lattes. Let f of x calculate the amount left on her gift card after x lattes. And again, they've given me this function here. What does the -5 represent for this situation? What does that -5 mean? Yeah, that's the amount I have to subtract off of my gift card balance for every drink that I buy. So this is the charge or the cost per latte. What about the 100? What does that represent? Yeah, when I get the gift card, that's the original balance. The original gift card balance. And we've got a graph here as well. Remember that our X represents our number of lattes. And our Y represents our gift card balance. Card balance. So let's talk about our domain. That's our number of lattes. What's a starting value that makes sense for our domain here? Number of lattes. What's the lowest number of lattes we could consider? You say 1. Do negatives make sense? Okay. So you're starting at 1. Does 0 make sense here? I've got some waffling back and forth here. What would 0 mean? I haven't bought any yet, right? So this would be like when they handed me the gift card, my domain value would be 0. Does that make sense? So we actually could start this one at 0 and 0 be an okay value. Okay, so I'm going to start our domain at 0 here. And then what's the top end of my domain? What'd you say? Why 20? Perfect. That's the total number of lattes I could buy, right? With my $100. Notice I'm putting brackets on both ends of the domain and range here because 0 is a value that makes sense and so is 20. Those are realistic values for the context of this problem. Now let's talk about our range. What's the lowest Y value I could possibly have? 0. Will they let me go negative on a gift card? No. They'll say your gift card's out. What else are you going to use to pay for it? So 0 is my lowest range value, and 0 is an actual value we could have. If I spend all of the money on my gift card, it would be 0. What's the top end of our range? 100. Yeah, the amount I start with on that gift card, which was $100. Questions for me so far? Okay. We have one more sort of bigger scenario we're going to take a look at next. And for this next one, we're going to do a little more of the heavy lifting. So for A and B here, we were given the equation and we were given the graph. On page 86, this time we've got to create some of that. So on page 86, example A here, says a bank account starts with $500. $20 is withdrawn every week for W weeks. Write a linear function A of W that represents the remaining balance. Okay, so I'm going to kind of model this off of our gift card problem from the last page. Okay, at the end of their function, they had 100, and we said that was the original amount on the card. So as we write our function, I'm going to call it A of W because that's what they asked me to call it. And then at the end, I'm going to put our original amount. How much do we have in the account to start with? What's our original amount? 500. Okay. I'm going to put plus 500 at the end. That's what I'm starting with. And then it says $20 is withdrawn every week. What does withdrawn mean? I'm taking it out. Yeah. So just like with our gift card example, the one we just did, they had -5, right? And that negative was because every time we bought something using the gift card, that took away from the balance. So I'm going to do the same thing here. We're going to take away $20 from that balance every week. And it says use W for week. So that's what I'll do here. So there's our function. We're starting with $500 in our account, and we're taking out $20 every week. Now we can create a graph of this function. And if you want, you can make a little table off to the side. That's fine. So I'll do that for a couple of these. Number of weeks, and then our account balance after those weeks. So when we start at week 0, again, I'm kind of treating this just like that gift card problem. At week 0, when I'm starting, I've got $500 in my account. That first week, I take out $20. So my total is going to go down by 20. So this would be $480. The second week, I'm going to take out $20 more. So now I'm at $460. The third week, I take out another $20, and now I'm at $440. Does it make sense what we're doing here? Every week I take out $20, so I have to take 20 off of that total. Okay, and then I can plot these points. So I'm labeled here weeks versus balance. So at 0 weeks, I'm at $500. At 1 week, we're at $480. So there's 400, 20, 40, 60, 80. At 2 weeks, we're at $460. At 3 weeks, we're at $440. And I'm going to keep going down $20 every week. So notice our X's are going by 1s. Our Y's are going by 20s. So for every week that I go over, I'm going to go down 20. And I'm just going to put my points on this graph. So for every 1 week later, I have to take $20 off of that balance. Now we've got some evaluate practice problems here. Again, good practice from what we did with our warm-up. My first problem is asking for A of 2. Remember, this is an X value here. It's in parentheses. So A of 2. So when X is 2, what's the Y value? When X is 2, Y is 400, 420, 440, 460. I could have gotten this one from my table as well. When X is 2, Y is 460. A of 0, I'll get this one from our table. When X is 0, Y is 500. And then the last one in this column is giving me a Y value this time, and I'm trying to find the X. So I don't have 140 in my table, so I'm going to reference my graph. So I'm going to find when Y, this is the Y value, when Y is 140, there's 100, 120, 140. I'm going to follow that across to the point on my graph right there, and I want to find this X. So there's 15, 16, 17, 18. So A of 18 equals 140. I would like you now to try these 3. A of 10 means our x value is 10. Follow that to the point on our graph, and we find our y value is 300. A of something equals 400, so we've got a y value this time. When our y is 400, here's our point. That x value is 5. So A of 5 equals 400. And then finally, A of something equals 0. That means our y value is 0. Follow that to our graph and find that x value. So that x value is 25. Questions on evaluating our function, those three problems? Okay, now let's talk domain and range. So domain, remember, is our x, range is our y. For our domain, what are the reasonable values here for our domain? Where does our domain start? At 0, yeah. I'm looking at when I initially put that money in the account. Okay, so our domain value would be 0 here. I'm using a bracket because 0 is a value that makes sense for our problem. And then what's the end of our domain? What's the largest value we could have? 25. Why did you say 25? Yeah, 25 would be the end of our domain because week 26, I don't have any money, right? That would be a negative y value, which is generally not how you want to run a savings account. So we would go to week 25 here because that's the last week that I can withdraw money. That's the last week that this pattern works. And then how about our range? What's the lowest amount of money I could have? 0, yeah. That would mean my account is empty. What's the highest y value I could have? 500, that's the amount that we're starting with. Okay, so domain and range there. And then I've got a couple questions about x and y intercepts. So we've seen and talked about x and y intercepts before. What's the y-intercept for this function? Yeah, y-intercept is where I cross the y-axis. That's at 500. So our y-intercept is 500. What does that mean in the context of our problem? So what does that 500 represent? Yeah, I'm starting at 0 weeks. You said I'm starting with $500 in the account. We start with $500 in the account, or at 0 weeks, we have $500. And then how about the x-intercept? What's the x-intercept for this function? 25. 25 is our x-intercept. What does 25 mean? What does that x-intercept mean? I guess I should say. Yeah, at 25 weeks, I've withdrawn all the money. At 25 weeks, we have withdrawn all the money. Or at 25 weeks, we have $0 would be another way I could phrase that. Question for me on page 86? Okay, I want to look at just the setup for the problem on page 87. So if you would for me, please turn to page 87. And we're going to take a look at the setup for this one together. So the top of page 87 says the student has a savings account with $475 in it. Each week, the student deposits $125 of their paycheck into the account. The student's goal is to save $7,000 for college. Write a linear function, b of w, that represents the bank balance after w weeks. Okay, so we have an initial amount that we're starting with. What's the difference for this problem? We're adding money to the account. For our last example, we were taking money out of the account. Here, we're adding money to the account. So I'm going to write this equation the same way I wrote the last one. So b of w, what they want me to use. And it says that I'm starting with 475. I'm going to put plus 475 at the end. And then we deposit $125 each week. So that 125, do I want it to be negative this time? No, I want it to be positive since we're adding on $125. So 125, and then it says use W for weeks. So 125W plus 475. So there's our function for this example. You don't have to graph this one. And then we've got a couple evaluate problems, domain and range, X and Y intercepts. So I would like you to finish page 87 for homework. We've got the equation that we set up together. I want you to finish it for homework.